So today we are going to cover adding and subtracting rational expressions. So let's first remind ourselves how to do this with just regular numbers. All right? Say I asked you to add, I don't know, let's say 3/7 plus 2/7. What do we say that these two fractions have? Common denominators. So that's a big old, you know what, I'm going to put that in red over here. This is a big deal. To add or subtract fractions, they must have common denominators. This applies whether, denominators. This applies whether we are just adding, regular fractions like you see here. It's also going to apply when we have a polynomial over a polynomial. You still need to have common denominators, all right? So let's recap though. Right here, I do have common denominators. Oh, how lucky for us. What did that get me? When I try to add 3/7 plus 2/7, it's 5/7. So remember what we did. We kept the denominator the same. Please notice, the denominator did not become 14. You do not add the denominators together. You only add the numerators, right? If you ate 3/7 of a pizza and 2/7 of a pizza, that means you ate 5/7 of the pizza, not 5/14 of the pizza. It doesn't make any sense.
That'd be 10/14.
Right. We're adding together. It's like if I have 3 apples and 4 apples, that's 7 apples, right? I didn't change apples. It just stayed with it. The same thing happens with fractions, okay? So let me give you one that has some polynomials in it. So let's say I gave you something like 3x over 4 plus x over 4. Well, right now you have common denominators, so life is pretty easy. You have common denominators. All you have to do is the same as when you were adding just numbers. I'm going to add my numerators and keep the denominator the same. So guys, what does this get me? 4x over 4. Now, just like we should have talked about that back up here, what should I be checking on 5/7? If I can reduce it. Can I reduce 5/7? No, I happen to have one that it couldn't be reduced. I run the same check here. If I have 4x over 4, is the 4 and the 4 cancels. Your final answer is actually just x here. Does that make sense?
Yes.
Okay, so let's try another one. I'm trying to pick a good one. I'm just going to make it up. Let's try, same thing with subtraction. Let's say I had, 6x plus 1 over, 2x. And I wanted to subtract from that 2x plus 3 over 2x. This one's actually a little bit trickier. Well, you got to think. What do you think? Well, let's start here. Do I have common denominators? Yes. So my new denominator of my answer is going to be what? Still 2x. The denominator is not going to change. Now I have to worry about the numerators. I'm asking you to take this number and subtract this number. So you have to be... Yes. It's going to end up being 4x minus 2. Why? Exactly. You're subtracting this whole number. So what you're really doing is 6x plus 1 minus 2x minus 3, because you have to distribute that negative to both of them. That's really tricky though, because normally you're not going to see parentheses here. I added those in. So it's up to you to understand, okay, well, if I'm subtracting a binomial or a trinomial or anything other than a monomial, you have to distribute that negative to everybody in there. And now I'm combining like terms. So what is 6x minus 2x? 4x. And then positive 1 minus 3 is? Minus 2. Now is this a final answer? 4x minus 2 over 2x? No, I can reduce this. And guys, now what it really becomes is a question like we did in, was it 12.1? Yeah, 12.1. No, I'm sorry, 12.2. So I'm just looking at this. Remember what our rules were to just simplify. Well, hold on. Look at your numerator. We went piece by piece. Hold on, guys. Piece by piece. If you just look at the numerator, is there anything you can factor out of the numerator? 2. So you take out a 2 and you're left with x minus 1, right? So that one's done. Is there anything to do down here? Can I factor that? No. Now is when you take out your other colored pen. And what can I cancel, if anything?
2.
The 2's. Do not cancel anything until you factored all the pieces. So factor, factor, there we go. So now I end up with a final answer of x minus 1 over x. Or is that a final answer?
Yeah.
Yes, that is a final answer. You cannot cancel out those x's. Why? Because this numerator is a binomial. The only way to cancel out a binomial is if you had the exact same binomial in the denominator. So if you had another x minus 1 over here, then you could cancel, but you don't. You cannot cancel a monomial with a binomial. That's such a big no-no. So don't do that. If you have a binomial, you got to cancel binomials with binomials, monomials with monomials. You with me? Okay. So now, let me give you one to try, and then maybe I'll stop the video, and then we'll try ones that have unlike denominators. Okay, so let me give you this one to try. I'm just going to make it up again. Try this one. Say I gave, ooh, I know. Let's do a trinomial up there. Well, I'll do the trinomial on the other one. Let's do over 3x. And then let's minus over 3x. Let's do an x squared plus 2x minus 4. So simplify this one as much as you can.
I have a question.
Sure.
In the top one, when you took out a 2, wouldn't the parentheses be 2x minus 1? 'Cause it's 4?
Oh my gosh. Thank you.
That's what
Yes.
I thought, and it's just-
No, you are correct. So our real, did everybody catch that?
No.
When we factored the 2 out from here, it shouldn't have been x minus 1. It should have been 2x minus 1. So over here, I should have a 2x minus 1 over x. Does that change this final answer now? Can I, well, now that I have the 2 in, can I cancel anything now that I couldn't before? No. So this is our correct final answer, right. You got to make sure you have the 2 there. Thank you for catching that. All right. So now, try this one here. Since you are subtracting, remember that you are subtracting this whole numerator here. So be careful. You're going to have to distribute that negative to everybody. And then you can proceed. Yep.
So you can't simplify any of the numerators? Like, couldn't you factor the second part?
You can, but it's actually not going to help you. It won't help you any. So even if you could, here's the other problem. If you, say this was a fraction that could be simplified, then you're going to make your 2 denominators not match anymore, right? And since I want to subtract these numbers with these numbers, you don't want to factor them yet. I may factor and cancel at the end if my answer leads me to that, but first thing, check that you have common denominators, and then just combine all the numerators. Then worry about factoring and canceling later on. Okay, does everybody have the next step done? So here's what you're really doing. If I have to subtract all of this, I'm really going to do 2x squared minus 1 minus x squared minus 2x, and then what? Plus 4, because it's already a negative. So I'm still going to have 3x as my denominator, but now I just combine like terms here. What's 2x squared minus x squared?
No.
X squared, right? So those are done. Now, negative 2x, there's no other x term, so I do minus 2x next. And then what is negative 1 plus 4? Plus 3. So now I have to check if this is a final answer or not. Well, it is, yes. But we should check, can I factor this numerator? Are there factors of positive 3 that add to be negative 2? No. So, but if there were, I would factor them and see if it cancels with anything in the bottom. It doesn't. So this is my final answer this time. Okay so far? Yeah? All right, so we're going to stop this video, and then in the next one, we're going to have unlike denominators.